Ya está transmitiendo, ¿verdad? En directo.
Apenas lo voy a pasar al canal, lógicamente nadie lo puede ver porque no aparece en ningún lado,
Ok, ok.
hasta que yo pegue los códigos en el del seminario.
Ya
Ya
está
ahorita
transmitiendo, ¿verdad?
no
En
sé,
directo.
en 3 minutos. Apenas lo voy a pasar al canal, lógicamente nadie lo puede.
Ok. Ellos entran directamente en la liga que les envíe, ¿verdad? En el anuncio de seminario.
Sí, en la de diagonal seminario.
Ok, ok. Así que tenías seminario, Ale, hace unos minutos.
Sí,
Ah, mira. ¿Y
ya
cómo les
terminé.
va con los seminarios en su grupo?
Bien, o sea, que pues ha habido poco trabajo, ¿no? Solamente Isabel y Sabino son los que han estado entrando al laboratorio, en realidad
Ajá,
para mantener los insectos.
ajá,
Y,
ajá.
¿no? Y pues ahorita estamos realmente comenzando bien con los seminarios, ¿no?
Ya,
Ya en
ya, ya.
forma, retomando, haciendo los planes para el futuro a ver, ¿no?
¿Están usando Zoom para los seminarios? La
Ujú.
plataforma de Zoom. Mm.
Sí.
Sí, nosotros, fíjate, también estamos haciendo seminarios de grupo por Zoom. Ahorita suspendimos el periodo vacacional, pero estamos por
Ujú.
retomar nuevamente.
Sí, nosotros apenas retomamos después de las vacaciones pero pues sí es muy importante, sobre todo para que pues, los alumnos estén enterados de los planes
Así
y
es.
que se sientan integrados en el laboratorio y así,
No,
¿no?
sí, 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 por supuesto, ¿no?
Sí, pero sí está gacho a
No,
ver,
pues,
ojalá que en septiembre ya podamos entrar a trabajar, no sé, ¿no? Se ve medio.
pues un poco más, ¿no? Porque ahorita estamos muy limitados, ¿no? El número de
Ujú,
personas. Yo tengo estudiantes que están yendo al laboratorio. Bueno, obviamente somos un grupo grande, ya ves, con Enrique y con Leo.
ujú,
Entonces, pues tenemos que organizarnos muy bien para el tema de los estancias de los estudiantes en laboratorio, ¿no? Tratar
ujú,
de hacer las estancias escalonadas en horarios distintos y
ujú,
luego compartimos laboratorio con Tonatiuh y con Laura, ¿no? Entonces ahí,
ujú,
pues es un espacio realmente donde se concentra un número mayor de personas. Ahí.
ujú.
Entonces, bueno, pues estamos tratando de organizarlo porque también los chicos, sus proyectos,
Pues se
pues
están atrasando, ¿no?
así
Ujú,
es. Sí, sí. Y digo, bueno, poco a poco ir activando algunas cosas. Digo, no se va a llegar, por supuesto, al 100% de los objetivos que teníamos considerados, pero pues tampoco podemos detener del todo las
sí,
cosas.
porque nosotros hemos trabajado mucho aquí, Mario y yo,
Ujú.
en escribir artículos
Sí,
y ya hemos terminado varios, o sea, hemos estado bastante productivos, muy bien,
cierto. Ah,
en eso sí muy bien, pero pues, o sea, no podemos seguir así, o sea, indefinidamente. Si no hay experimentos, no va a haber avances. O sea, vamos a acabar con esto y luego qué, ¿no? O sea,
totalmente,
que
sí.
todo se
Sí,
está estancar, o sea,
sí, sí. De pronto se acaban los resultados para ponerlos en los artículos.
sí, o sea, no puedes, o sea, no puede, ¿no? O sea, necesitamos más, o sea, sí se requiere tener
Más
más
datos.
datos, más, ajá.
Así es, así es. Ah, qué cosas. Pues bueno, vamos a ir viendo cómo evolucionan aquí este tema. Déjame ver. ¿Ya está en vivo, Omar?
Todavía no lo pongo en la página, pero ya está todo.
¿Ya?
Ya está todo. Lo de que me digan, ya lo pongo en la página
Ok. Sí,
del
tenemos
instituto.
todavía unos minutitos para iniciar.
Unos 2 minutos, ¿no?
Sí, yo simplemente hago la introducción, recordarle los seminarios que sería para la próxima semana y ya le pasaría al el
Porque
micrófono.
ya me están preguntando si ya.
Ajá, sí, ya me imagino. Ya están llegando, les digo, ahí al auditorio, ¿no? Ya se están ubicando
Sí,
en las butacas, ahí en las sillas.
sí. Entonces ya lo voy a poner en el código.
Ok.
Perfecto, gracias. Adelante. ¿Listo, Mar?
Listo, ya debe de verse.
Ok. Pues inicio, ¿no? Para dar simplemente la entrada al seminario. Tú me dices, Omar.
Listo.
¿Ok? Bueno. Pues vamos iniciando entonces con la presentación. ¿Qué tal? Buenas tardes, buenos días a todos y bienvenidos nuevamente a nuestros seminarios institucionales en esta nueva modalidad que estamos manejando ahora, que es a través de este sistema virtual. El día de hoy tenemos un seminario muy interesante, seguramente para todos. La doctora Alejandra Bravo va a hacernos favor de introducir a nuestro ponente invitado. Les adelanto, es un seminario que se grabó la semana pasada, ya la doctora Bravo les dará un poco más de detalles. Y simplemente invitarlos para que sigan nuestros seminarios. La próxima semana continuamos con otro invitado, van a ser a las 12 horas ya de manera regular. Y estamos explorando que sea en la plataforma de Webex, que es la misma que utilizamos la semana pasada. Y bueno, pues nada, le pasaría la palabra a la doctora Alejandra Bravo. Adelante, Alejandra.
Hola, buenas tardes, buenos días a todos. Estoy muy contenta de poder presentar al doctor Jie Zhang, que él trabaja en el Instituto de Plant Protection de la Academia China de Ciencias, que se ubica en Beijing. Este instituto es un instituto muy grande, tiene aproximadamente unos 140 investigadores que trabajan ahí y muchos estudiantes. Es un instituto dedicado a la investigación y a la docencia, ¿no? Sobre todo con estudiantes de maestría y de doctorado. Es el instituto donde nosotros colaboramos en China, sobre todo, ¿no? Y tenemos varios colaboradores en China, pero este es uno de los grupos más importantes con los que estamos colaborando actualmente. Y por eso para nosotros es un gran placer que aceptara dar esta presentación. En realidad, pues me hubiera gustado muchísimo más que fuera de manera presencial, como estaba originalmente planteado. Y entonces, como les comentaron, esta presentación la grabamos la semana pasada y ahora la transmitimos en este horario. Ya sería imposible casi que el doctor Shah nos hiciera la presentación porque es la 1 de la mañana de mañana, ¿no? Del 11 de agosto en Beijing. Entonces, el formato de la presentación pues, tiene algunas deficiencias de repente porque hubo un corte de internet a la mitad, entonces hubo que juntar la presentación en dos mitades, pero se puede ver bien y las preguntas queremos pedirles que me las manden a mí por correo a mi email y yo se las voy a transmitir al doctor Zhang posteriormente para que él pueda hacer los comentarios pertinentes a los que hayan hecho esas preguntas. Y pues de esa manera sería el formato de la presentación y de este seminario. Y el tema se centra en el control del insecto, que es muy importante, que se llama Spodoptera frugiperda. Este insecto es conocido como gusano cogollero normalmente, o también se conoce como fall armyworm. Es una plaga sobre todo de maíz y de arroz, pero es polífaga, come muchísimas plantas y es un insecto que ha sido invasivo. Existían antes únicamente en América y ahora ya se desperdigó por todo el mundo, llegó a África y de África se fue hacia Asia y entonces es un problema ahorita muy, muy serio en China. Tienen 2 años de que les llegó esta plaga a China y ustedes, o sea, la plática del doctor Zhang va a ser todas las acciones que ellos han tomado para combatir a esta plaga únicamente, que ha sido un trabajo, como lo van a ver, global, súper grande, donde están atacando por los diferentes frentes que se puede atacar a un insecto plaga, como lo ven, ¿no? Insecticidas químicos, insecticidas biológicos, de todo tipo. Entonces espero que pues, pueda ser interesante para muchos grupos que trabajan con diferentes organismos en el instituto. Y pues estaremos listos para empezar la presentación cuando ustedes digan, que no sé si esperar un poco más de minutos o ya empezamos. Como usted, yo estoy totalmente de acuerdo en que empiecen cuando quieran.
Ok. Gracias, Al, muy amable. Omar.
Listo, a la hora que gusten, lo ponemos.
Adelante. Sí, ya, si quieres pasar la presentación, adelante.
Omar, no sé si se escucha, yo no escucho nada.
Sí, yo tampoco escucho la presentación.
A ver, lo voy a volver a poner.
Ok, gracias, Omar.
OK. Can I begin now? Yes.
Yes, please.
OK. Thank you very much, dear professor, dear colleagues. It's my great pleasure to introduce some of the armyworms works in China. As I know, I will introduce some of them, the policy, the technique, and the biocontrol for these insect pests. So the topic today is I will introduce the armyworms' current situation and research and controls in China. Here's the outline, the 4 parts I will introduce today. First part, the background information. As you know, this is insect is very famous in America. It's very heavy damage. It can be harmed from the seedling stage to the ear stage, reduce the yields around 20 or 40% for serious no harvest to the crops. Especially for these insects, adults can fly more than 100 until to the 1,600 kilometers. It can fly quite long distance. Strong reproduction abilities. I think it's more than the common moth, just like cotton bollworm and others moths. And the first efficacies for the chemical pesticides, and most of the pesticides for these insects, the resistance from them. So the FAO say that this insect is a top 10 pest in the world. This picture shows the route of this insect from the America to the Africa 4 years ago. The first spot is about Nigeria. After 3 years, almost the 26 countries in Africa found this insect. And 2 years ago, 2018, this insect moved to the India in the May of 2018, found in the India. Then moved east to the Bangladesh, Myanmar, and end of the 2018, found in the about a border of China, between China and Myanmar, Yunnan province. So the January of 2019, found in China in the Yunnan, Lantang, the really areas. So after that, it moved to the South Korea and Japan, and the south part to the Australia. So it means that most of the East Asia countries found this insect pests. In China, in the last year, in the whole years, from the southwest part near the Myanmar, spread to the central areas. Finally, from the January to the September, in Beijing found this area. So from here, from Yunnan to Beijing, around 2,000 kilometers. So across the almost the mainland land of China. Occurring of fall armyworms in this year's only the 6 months up to the end of the last month, around the less than last year, around 927,000 hectares, and only the 22 the province found these insects, and last year. But the region, south part of the China, the south of the Yellow River, maybe you know, very heavy the rain, stormy rain, and the flood. So its factors affect this insect move the north part of China. The part two, the progress of technology. So several parts, including this picture. Grasper's rules focus on the emergencies, explores the mechanism, and managing sustainably. Consider both surface and root. Firstly, I will introduce grasper rules, accurately prediction, migration routes. The monitoring and early warning technique platform for armyworms was constructed early of the last years. Set up the insect radars in the Jiangcheng, Lantang, Rili, and other places in the Yunnan province, near the Myanmar, the country. Combined with the data from the National Monitoring Station and Field Test Station. So that I remember in the May of the last year's President Xi signed a file, asked the Ministry of Agriculture to control this insect. So from there on, the central government, including the Ministry of Agriculture and the Ministry of Science and Technology, set up different projects. I remember first project around 10 million Chinese yuan, about 1.5 million US dollars. These two projects. And early of this years, the central government gave the big project around 6 million US dollar in 3 years to research and develop a new technique to control this insect. So here the migrated to China early of December 11th, 2 years ago, from Myanmar to Yunnan. Here's some station staff working here found some adults near the borders area. Developed a technique of trap and reporting. That's about trapping lamp, monitoring of occurrence of adults, prediction of dynamics and largest occurrence periods to develop the rate. So this is after dissections from the female's mouth and from the different part and develop their wells. This means after the mating, they can migrate to the other place with the adults by the tracking lamp. Developed the technique of a sex pheromones, attractant, and forecast for adults. So this is a new material and a new technique to use monitoring for this insect in from the Yunnan until to the Beijing, almost the country use this the trap to test the female male mass. According to male mass number, to deduce the females numbers in the field, and can predict the number and the population of this insect in the next generation. Developed the intelligent identification systems for armyworm. Use the mega data and different information system to predict the insects from the eggs, the larvas, adults. And they use this system can use by the mobile phones. The people working in the field can read and find this data. It's very easy system. Establish a forecast system for the population of armyworm. Establish the different websites to publish the data. So the population forecast systems, including this from the eggs to the adults. So this system is supported by the local government, both the local government and the central government in our Ministry of Agriculture. Clarify the signal migration and the harm of armyworms. Provide basis for the monitoring and the earliest warning of foreigner pests, sources, domestic, annual breeding areas, migration, transition areas and the key provision area. So that's the three the parts. This means this near the Myanmar, Laos, Thailand, and here's near the Vietnam, and this part from the Philippines cross the sea. So long distance migration of the spotted vertebrates across the South Sea of China was confirmed by the radar and the tramping lamp. This is the Rongxing Island in the middle of South Seas of China. It's south part of China, near these islands to the Hainan Island, about 280 kilometers. To the Vietnam, and here, from here to here is about the 400 kilometers, and from here to the Philippines, around 780 kilometers. So from these islands, it can capture the mouse from the Vietnam and the Philippines. So it means cross the sea from the Vietnam or the long distance from the Philippines can be confirmed last year. Army worms migrate across the Bohai Sea between the north part and the northeast China. The northeast China, including 3 provinces, is very big crop yield areas of China. Every year, the yield of the crop from these 3 provinces is about 20% of the whole country. So it's a very serious crop yield areas. But this is the Shandong province. This is the Bohai Sea. So the army worms can cross here, from here to the north part is the Liaoning province. This distance is around 100 kilometers. So for the monsoons, the region is near the Pacific Ocean. So the wind blows from here to the south to the north. So this mouse is very easy cross the sea to the northeast part of China. So it's the middle areas. It's a very famous experimental station of our institute. We mean the Beihuang station. So in this island, we set different radar to monitor the migration of the different insects, including the fall armyworm and the cotton bollworm and the other insect pests. Sometimes we can find a lot of natural enemy migrate from between the Shandong to the Liaoning. Yeah. In the May, every year in the May, the insects from here to the north part. And when the winter comes, the end of the September, a lot of the insects, including the insect pests and the insect and the natural enemy, return to the mainland of the Shandong and northeast of China. Insects is very serious. So from the early of the last year's Ministry of Agriculture recommended some chemical pesticide and bio pesticide. Urgencies screen of the prevention and controls agent to provide technical supports for the recommended list. Here's only a lot of the chemical and pesticides only in Chinese. Here's 8 kind of the single formulas and 14 kind of the multiple formulas mixed together or one by one. The different method to screen the new pesticides. Before that, there were no any products registers against armyworm. So on the June of last year, some company began to register different insecticide for the control of the armyworms. So this is a how to say that systemic insecticide test in the lab. So to control the armyworms, it's very nice the result. Research and the development of precision low values sprays technique. So the method using a different machine is very, very important. So to save the pesticides and to avoid pollution of the chemical pesticides. So this technique is a very important and used in the field. Exploring mechanism and studies characteristics of disasters. We found in China, we found armyworm, the host plant, around 19 kind of crops. Favored crop is corn, soybeans, sugar cans. And end of last year, we found that millet, wheat, potato, and weeds in the field. They like it, all of them. Biological characteristics don't harm the period from the emergency to the maturity, and can harm weight of the damage loss. Yield lost about 173 levels in the 100 plants. Was the trees to lay a foundation of a formulation of prevention and control indicators. So we began the foundational research, also including the developmental starting to temperature. So we found that the south of the Yangtze rivers, the pupils and the old levees can cross the winter, can be crossed the winter and develop well. But after this line, the Yangtze rivers, in the next year, we cannot survive. To determine the genomic type of Chinese invasive armyworm. Maybe Ali and Maria knows Yutal Shells working in another institute of our academy. I know he collaborated with your lab now. Yeah. It sequences several the economy of for armyworms. So the genome of the 103 individuals from the 50 countries counties in the 16th province was resequenced. From this result, it was determined that the invasion population of the grassland was the farming worms was the maize type, which originated from the Florida in the eastern United States, indicating the key points of the construction of the control system. Maybe the resistance to the chemical pesticides is similar with that in Florida. I don't know how, which genomic typing in Mexico or your province, maybe similar, maybe not. Managing sustainably investigate and develop varieties of prevention and control. AMP induced the errors arresting technique, the technique of attracting and killing natural enemies, insect pest control technique, the technique of controlling pests with bacteria or the fungi pesticide, seed coatings, introduce the achievement of this technique and products. Firstly, the insect readers intelligent multi-spectral trapping lamp system was developed and working very well. The altitude and densities of the moth was monitored in real time. Control insect lamps to realize the precise trapping and kill of the Spotoptera peda. And this it's very nice the result of the food attractant. It has been broken through the and killing farming worms, moths. So because lots of both the male and the female adults, when they migrating the process, they need to feed some food, including the pollens and some of the fragmented materials. So we use this trait. So this is before that, and it's after they use the food attractants. So the females, the mouse, and are equivalent to kill the larvas. That's damaging the one move. It's around 600 square meters. Application to natural enemy of insect. So a lot of the native natural enemy found in the field. I continue to talk on natural enemy of insects to control the farming worm. The local natural enemy found in China, including stink bugs, ladybugs, lacewings, flies, and other natural enemies. In a different province, there are different factories to produce these insect pests, natural enemies. Sorry, increased number of natural enemy in the last years around the 10 millions. In Yunnan and Guizhou province, in the field, a lot of the natural enemy working well. Some of them efficacy to control the fall armyworm around 70 to 80%. Yeah, for the microbians insect pests, including Bt and fungi and the virus, I will introduce more of this because our lab working on the Bt. So in this strain, the Bt-G 0338 is the first engineered bacteria registers in China. So this the host strains containing CRA1, 1A, 1C, and VIP3 genes. We transformed CRA3A gene to this native strain. So the engineered strain contain actual CRA3 gene. So the targets can control the lepidopteran pests. And another function is leaf beetle. So this is Chinese government proposed the experimental reports for the registration of the pesticide. In last year's, we finished in 8 provinces, including the Guangdong, Guangxi, Yunnan, the other 5 provinces, field trials to test this product to target insect for armyworm. So this is in the Yunnan province, the Jiangcheng near the Myanmar. The May of the last year's. This is before the show. You see all the seedlings. It's terrible. Nobody is fine. So this is all the leaves still very bad. But the leaves after controls treated by the Bt grows well. Almost the insects was killed. So the efficacy around 85. So we are very glad because the Bt control the farming was in this level. So after the whole years, we found in the different stage of the corn. So the different the Bt products used to control different insects. The south part, especially in the Yangtze rivers, in the fields, the different instar larvae mixed together from the neonate to the 4 or 5 instar. So it's very difficult to control. So for the firstly, just in the neonate, in the 1,500 grams in each hectare, it's easy to control the neonate of the armyworm. But in the different mix larvae in the fields, so the Bt should be used more and more around this for each hectare. For the year, the stage to spray Bt is not a good result to control this one for armyworm. So we tested not only the Bt, this is from one company, this is from our to control them for in the 7 days in the week. So this is the result. But for the larvae, the big age the larvae, Bt is not so good. So we screen with collaborate with the company, use the chemical pesticide. So both of them can control well. So around the 100%. So it means can decrease the chemicals used in the field, both in the BT, containing both BT and the chemical. So it's very useful to decrease chemical pesticides used in the field. So this is a different strategy for the neonate, for the first install control used less the BT, and for the serious the field used both BT and the chemical pesticide. And in June, in the Anhui province, collaborate with a local academy. Anhui province, we tested BT products in the field. So this is the results for the diet, the insect. We tested more than 10 chemical pesticides, and the BT is two one from our lab, and this is a fungal pesticide, and is a virus, the pure virus, and this is for the amamectin benzoate with the chemical. This is a very famous chemical from the DuPont company. So mixed together, it's more than 90% results. For the BTs, in the 2 weeks, the controls did very well. For the fungal pesticides, it's not so good. It's around 50 to 60. But the insect virus, the single virus is quite good. And combine the BT and BT with the fungi and the BT with the virus, the results is quite good. That it means different biopesticides can synergy together, or the results to control the insects is quite good. I think the efficacy is more than 80%. It's very useful to do this combination. As we know, almost the daytimes, the leaves and the base of the leaves. So our institute, another group, invent this for formulas, both in the chemical pesticide and the BT. The first times we tried this formula and use a new equipment, non-manned real vehicles like this one. Yeah. It's made in China, the local company. So this is not like spray the liquids, the chemical. This is a centrifuge. It can spray particle to the crop leaves. They can spin very fast. This is granules products of BT products. So it's red color. It means it's easy, convenient to investigate in the field. And this is to fill the products in this tank. This is the in this field, the students can search the flag here and the vehicle flag across there, you can wind. Yeah, so you can find this place, stop or not cross this area. I'll show you the when it is sprayed flags. Yeah, in the field trial, you can fly it like here. It's a shadowing. It's a particles sprayed outside. The people can control these vehicles around the 150 centimeters. So this is particle can spread around the diameter around 4 meters. It means the lines, the cones can be sprayed well. So yesterday we received the results. The control is the BT products sprayed different the dosage, 1 kilometers, 1 kilogram up to the 3 kilogram. The 1 kilograms contains 100 grams BT products. Yeah, this is a sprayed liquid chemical pesticide. So the controls efficacy no more than 60%. But for these granules, the formulas, it's quite good because these particles sprayed in the basic of the leaves. When the rain and the water is there, they can resolve, can form very high concentration. If at that times the larvae of a fall armyworm hits the leaves, they can kill it very easy. So these new formulas, we think it's a potential to commercialize in the field to control these insects. Yeah, another very interesting result, not only the BT products, but it's related with BT. This is a GMO, the BT, transformed or VIPS3 the gene or CRY2 gene in this variety. This experiment field trials finished in the Yunnan province last year. So this is a transgenic. This is the controlled crops. So this is without transgenic corn is quite good, but this is control. So we found this very interesting result. Because in the GMO, the corn, no insects damage this seedling. It's quite good. So the following the adults found this intact the seedling. They will they are hatch their eggs in these crops. For this very poor the controlled the corn, no the adult mouse went there to lay the eggs. So it's very interesting. Maybe they need they hope their babies have enough food to grow up, to eat, to grow up. So this is mean the BT maize as a bait to kill the farming worm, can provide ecological control strategy for the other crop. So it became GMO the field. attract the adults amount of mouse of farming worm to lay their eggs, but they have no next generation. All of them will, almost them will, will be killed. So besides these results, we test the different fungi in terms pesticides. So this is from the Chongqing cities. That's the commercial item name is Chongqing 421. It's quite good to the different insects. This is tested in the field around 70 efficacy. But the combined with the BT is the 421 the products is commercial. The names is out. So after the week on 10 days, the result is quite good. So this combined with the different chemical pesticide also showed a very nice results after the 3 days. So it's much better than the native fungal pesticide. Another one introduced nuclear matrices, the virus from the aptitude to pest. This is a local companies in China, different dose in the field. The results to control the farming worm shoot here is quite good. It's more than almost all of them results are more than 80% control this insect. So after the 1 year's works, the whole government, the central government, and our academy and our institutes give a great support for the research. And we have a lot of the collaborative partners in China, different provinces, working in the Academy of Agricultural Science and the agriculture universities. They made a big the web to collaborate together. So our summary for the microbial pesticide, the BT engineered the strains and the native strains and the fungi pesticide and the nucleus polyhydrosis, the virus, and other products can effectively controls farming worms wells. The BT products and others products and conventional chemical pesticides have a significant synergy effect. So to control, our suggestion is to control the different insects and use the different products and a different strategy. For the synergy effect among the BT, fungi, pesticides, it's very important. So to control them, to control this insect, we can choose the different combination. Ordination of the BT fungi, virus, and others, microbial pesticides, natural enemy, chemical pesticides, combined cultivations. Sometimes we should consider water, fertilizers integration technology together to establish a technical regulation for this insect pest control. So this is our governments need this, and the farmer need this combination. So the solution of restrictions governance is proposed. So after the whole country's network working for this insect, and the suggestions, including here, the annual breeding areas, including the Guangxi, Yunnan, Guangdong, Hainan province, control the pest source from the abroad, from the Bangladesh, from the Vietnam, Myanmar, Laos, and so on. Reduce the breeding base and reduce the number of migration. In the area of transition zone, including the Hunan, Hubei, Chongqing, Sichuan, Zhejiang, Jiangsu province, trap and kill the adults, control the larvae, and disperse the base of the transition insect source. Key prevention area is in the north of the Yangtze River and south of the Beijing areas. Maybe it's a main area. Man focus on their prevention and treatment of a young larvae, control the occurrence of a spot-like. Regional governments bring prevention and control solution. Move the transition zone. There's a different system to block the adults' mouths. Use the radars monitor and the warning, and gas brought lights. The monitor is interception in the sky. Yeah. And trap the adults. This means that keep one the adults. This means as a keep the 1,000 larvae. Low worms source, so and control the larvae. So in the different region, we push the different method and strategy for the government and the farmer to control this insect. Reduce the pressure of prevention and control in the key prevention area. So to the conclusion of my talk, the grand harvest guaranteed by the insect infestations in 2019. The current scales of Staphylococcus aureus was significantly controlled, and the damage loss was controlled below 5% in the field, making outstanding contribution to ensures the high grains yield in China. Leading scientific and technological innovations in prevention and controls, research and development of the monitoring and early warning, emergency controls, biological controls, physical and chemical control, the chemical controls technique that to significantly improve the effectiveness and level of prevention and control of the Chinese farm armyworm. Construction of a sustainable control system based on the occurrence characteristics of the pests, counters the measures of the regional controls are proposed to build the advanced grain controls technology system So this is my talk. Thank you very much for your attention. Thank you.
Okay. Thank you very much. This was a very interesting presentation. It's impressive the efforts you are doing to control this pest and other pests in China. As you know, this pest in Mexico is very important. So it's for us, it's very nice to see how you have what you have achieved, and I'm sure this will be very interesting to the other people in the institute. So thank you very much.
Pues gracias, Omar.
Listo.
Muchas gracias a todos por la ayuda, por la presentación del seminario. Y...
Gracias.
Pues gracias, Omar.
Muchas gracias, Omar.
Listo. Nada, listo.
Muchas gracias a todos
No,
por la ayuda, por la
se oyó
presentación
bien,
del
fíjate
seminario.
que... Gracias.
Pues gracias, Omar.
Muchas gracias, Omar.
Listo. Nada, listo.
Hasta luego.
Gracias a todos
Hasta
por la ayuda,
luego.
por la
Se oyó bien,
presentación del
fíjate
seminario.
que...